To do this, I'm going to compare it to counting as you're used to counting in decimal. 10 numbers, and that is base 10. Okay, when we're counting in binary we only have two options. We have a 0 or a 1, because if you look at any digital device, it's based up of components, and the components are either off or they're on. So we have a 0 for off or a 1 for on. So everything in digital is in binary, and binary then is only base 2. Okay, so when we look at base 10, which is our normal method of counting, we have the ones place, we have the tens place, we have the hundreds place, and we have, let's put a T there, for the thousands place. And if we look at this, like 10 to the power 0 is the 1 place, because 10 to the power 0 is 1. 10 to the power 2 is the tens place. Sorry, apologies. 10 to the power 1 is the tens place. 10 to the power of 2 is the hundreds place. And 10 to the power of 3 is the thousands place. So for example, if you wanted to write 12 in base 10, we would have 1 10 plus, we would have two twos. Two twos, okay? So we'd have 1 10 and we'd have 2 twos. Or if you wanted to write the number 741, we would have 7 hundredths, we would have 4 tens, and we would have 1 1, because we have all these options here. When we're counting in binary, we only have two options, okay? So instead of having the ones, tens, and hundreds place, we have the ones place, we have the twos place, we have the fours place, and we have the eights place. Okay, so that would be 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. So if you had the number 12 and you want to count in binary, then 12 would be equal to 8 plus 4. So we have 1 8, we have 1 4, we've no 2s, and we've no 1s. So that would be 12 in binary. If you wanted to then say, we'll say 7, how do we write the number 7 in binary? Well, it's 4 plus 2 plus 1. So it's 1 4, 1 2 plus 1 1, and no 8s.